Lesson 4-3, Relate Transformations and Congruence. In this lesson, we're going to talk about 3 types of motions. And first, I'm going to define what rigid motion is. Or in other words, isometry, rigid transformations, or congruence transformations. These are just 3 other ways to say it. And rigid motion is a transformation that preserves, meaning it keeps the length, angle measure, and area the same. So the first kind of rigid motion we have here is reflection. It just so happens when an object is flipped over the line of reflection so that the figures face the opposite directions. So I have a pre-image right here. And line K is my line of reflection. And once it's flipped about this line of reflection, this image remains the same. And then we have translation. That's when an object, so this pre-image here, is slided a fixed distance in a given direction. So the final image will face the same direction as the original image, which is the pre-image here. Okay, and now we have rotation. Rotation is when you rotate a figure about a fixed point called the center of rotation. So this is the fixed point. And you can either rotate the pre-image or the original image clockwise or counterclockwise. So for this example here, I am rotating the pre-image counterclockwise a certain degree here. And again, the image, the final image here, the length, the angle measures, and the areas don't change. So I want to say that for all 3 types of rigid motions, the original object is called the pre-image, and the transformed is called the image. And the transformed image is labeled using a prime symbol, A prime, B prime, C prime. Example 1. Describe the transformation or transformations you can use to move figure A onto figure B. So for the first example here, figure A is the original image, and it's being rotated a certain degree, and then reflected about a line of reflection. So this is the line of reflection. So we can first write rotation. So this part's the rotate. And then reflection. Okay, let's look at the next example. Your pre-image here begins here. This is your A image, and this is your final figure B. So first we have a translation. Figure A is being slided to the right, and then the green triangle here is being again reflected about the line of reflection. So this part is reflect. Okay, part C, again we have A, and this is B. We have translation again. And then, from this point, this image is being rotated about a fixed point. So this is a fixed point. So we have rotation. Example 2. Tell whether a rigid motion can move figure A onto figure B. If so, describe the transformation that can be used. If not, explain why the figures are not congruent. So if we look at part A here, figure A, if we were to translate it, we can map this side, but the other sides would not be congruent. Therefore, I would write no, a translation maps one side to a congruent side, but the other sides are not congruent. And if we look at part B here, for figure A, if we do a reflection in the x-axis, so we reflect this about the x-axis, we can match every single part of the image. So I would say yes, a reflection in the x-axis maps figure A onto figure B. Example 3. Designs for floor tiles are shown below. Describe the rigid motions that can be used to move figure A onto figure B. So here we have this picture here, this figure, and if here we have a fixed point, I can rotate it clockwise to get to figure B. So I could say rotation 90 degrees clockwise. Okay, and for part B here, I can take figure A, I can translate it down here to, this could be my next picture, and then I can do a little reflection about this part to get my figure B. So I could write translation and then reflection. Now I'm going to give an overview of transformation notation. Now let's first look at the common reflections. The first one is about the x-axis. If we reflect about the x-axis, then the x-coordinate will still remain the same, but the y-coordinate will take an opposite number. So if we look at the coordinate 1, 4, we reflect that point about the x-axis, then the x-coordinate remains the same, and the 4 will take the opposite, which is negative 4. And for a coordinate point or an image that's reflected about the y-axis, the x-coordinate now will take the opposite, and the y-coordinate will remain the same. So if we look at this point and we reflect it about the y-axis, then the x-coordinate takes the opposite. The negative 1 becomes a 1, and then the 3, the y-coordinate, remains the same. So same thing, if I were to flip it the other way around, then the positive 1 would become a negative 1. Now we have a reflection over the line y equals x. Now for this one here, reflection over y equals x, the point such as negative 5, 1 is going to be reversed and becomes 1, negative 5. And if it reflects over y equals negative x, then, for example, if we have a point x, y, would then be not only reversed, both coordinates would take the opposite of the original. Now, if we have a reflection over any line, we've got to be careful here. Let's look at the point negative 5, 3. And if we reflect that point now over the line x equals negative 2, the y-coordinate 3 remains the same, but the x-coordinate doesn't. We need to first make sure how many units is it away from the line x equals negative 2, which is 3 units. And we need to make sure that takes 3 units to the right. So now I would like to move on to translation now, and it takes the mapping notation xy coordinate arrow to x coordinate plus a, meaning how the number of units shifted to the right. The addition tells us it's right. Okay, and then the y coordinate, it tells us how it's shifted upwards by how many units. Okay, so it's upwards because of the addition sign. So if we have a subtraction sign, then it will be downwards. So then now here we have an example of a translation of 6 units to the right. Let's just look at one point here, -4, 4. Okay, so since there's only a translation to the right, the y-coordinate should remain the same. So I can do -4, 4, arrow, and I can take -4 plus 6, and the 4 remains the same. So this would be 2, 4. That's how we do it. And then we have an example here where you have 6 units to the left and 3 units upwards. So if we just look at the simple example here, 1, 1. 1, 1. So 6 units to the left, 1. Let's see, 1, 1. We have 1 minus 6, and then 3 units up, 1 plus 3. So that would give you -5. I'm sorry, 4. So again, so I moved to this point, moved to this point. Okay, so 6 units, 1, 2, 3, 4, 5, 6, and then 3 units up, 1, 2, 3, to point -5, 4. And the same one would go for all the other points. Okay, I'm going to show you 3 common graph rotations. And the first one is a rotation of 90 degrees. Okay, if we look at a rotation of 90 degrees, if we look counterclockwise, I'm going to just look at 0.45 for now. And C is 0.45. And once we rotate it 90 degrees, it's going to land on -5,4. So what happened here? The x and the y coordinate, they were reversed, and the y coordinate will take an opposite sign. And for a rotation of 180 degrees, the x and y coordinate just takes opposite signs. So if we look at 0.25 here, so C is 2,5, and we've rotated 180 degrees, point C would just be -2, -5. And now let's look at a rotation of 270 degrees counterclockwise, and let's look at point D, 2, 1. Okay, so we move it this way. D would end up at this point here, and it's going to become 1, -2. So what happened here? From an x, y, and then y and x reversed, and then x takes the opposite of the original. Okay? Example 4. Sketch the image of the figure after the translation. So I've already labeled all the points of the figure. And if you want to be really careful about this, I would do it this way. Otherwise, you can just eyeball it, which I don't recommend. So I can take a -5 here. I'm going to add 7, which makes 2. And then 5 minus 3, meaning the picture's going to shift down here, will be 2. And then -2 plus 7, 5. And 5 minus 3, 2. So I'm looking at this point. And we look at this point. -1 plus 7, 6. And then 1 plus I'm sorry, 1 minus 3 here will be negative 2. So I'm going to plot all these 3 points now. 2, 2, and then 5, 2, 6, and then 6, negative 2. And then I'll have a precise image here. Translated image. Okay, example 5, it wants you to do the exact opposite as example 4. So we want to sketch the original figure. So I need to reverse all of these. So I've already listed all the points of the image that was already translated. So I just need to find the original points here. Negative 3 plus 5 is 2. 3 minus 2 is 1. Negative 3 plus 5 is 2. 1 minus 2 is negative 1. 4, negative 1, and 4 again. 2 minus 2 is 0. So now I can sketch the original image. So 2, 1 be here, and then we have 2, negative 1, and 4, 1, 2, 3, 4, negative 1, and then we have 4, 0. This is the original image. Okay, and we'll continue the lesson in class.